Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. If I split this shape into two sets of 6 blocks, when we're asked to shade in 3/6, for each one of those, or each set of blocks, I'm going to shade in 3 of the 6. So that's 3 for the first set, and this is 3 for the second set. And that's our answer. Now you might notice that 3/6 is the same as a half, because we can divide on 1 by 3, and so all I need to do is shade in a half. Or you might convert 3/6 into 6/12, and there's 12 squares altogether, so it's 6 of the 12 squares. There's lots of ways of doing this question. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. So we can draw out our place value grid to help us out with this question. We've got thousands, hundreds, tens and units. So we'll need another one there. So thousands go here, hundreds here, tens here, and then units here. So this says 2,000, so a 2 will go in the thousands column. 30, so that'll be a 3 there, and 2. So we need to fill in a 0 here to keep that 2 as 2,000, otherwise that would collapse and it'd become 232. So the answer is 2032. In this question we're given 13 lots of x and we're adding 7 lots of x to it. So if we have 13 lots of x and we're adding 7 lots of x, we're going to have 20 lots of x, or 20x. In this question we're given the output as 53, so we know that the output was 53. So now we've kind of got to work backwards, and when we work backwards through a function machine or a number machine, we do the opposite of what it says. So this first one says +9, but when we go backwards we do the opposite, which is take away 9. So we do 53 take away 9, which is 44. Now we can check that by going the other way, so 44 plus 9 is 53, so that works. The next one says times 4, so the opposite would be divided by 4. So we're going to do 44 divided by 4, and that gives us an input of 11. Now let's check the whole thing. We put in 11, 11 times 4 is 44, 44 plus 9 is 53, so we know we've got it correct. First thing to do when working out what angle things need to be on a pie chart is to add up the frequencies. So we're going to do 14 plus 7 plus 3, and we find out that that's 24. Then we're going to find the angle that one item would be. So one item is going to be, well, there are 360 degrees in a triangle, and there are 24 items. So we're going to do 360 divided by 24, and that gives us 15 degrees. So each item is worth 15 degrees, or will take up 15 degrees. So to find out the angle for red, well, we've got 14 items, times it by 15, and that will give us 210 degrees. And we're just going to times each of these by 15, which would be 105, and the final one times 15 is 45 degrees. Add them up and they add up to 360, which is good. They need to add up to 360. So we got our protractor, rest it on the pie chart. Now we know 180 is down here, so the first thing we're going to do is just mark that on, because the first angle is going to be 210. So We know that's 180 so far, so I'm going to turn my protractor around, and from 180, 210 will be another 30, so I'm just going to plot that on, and then I'm going to join it up. So start at the center and join that up, and we're going to stop when the circle stops. Then to do 105, we're going to put our protractor in the middle, and we're going to look at 105, which will be up here, and then we're just going to join it up with a straight line. And then we're just going to check the last angle, and so if I put my protractor on it, and it is 45 degrees. Perfect. Now, an important step to not miss is you need to label them. And so the first one is red, the second one is blue, and then the final one is other. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. To find a coordinate, what we can do is we can start in the middle and we work out how far across we have to go. And here we have to go 2 across, so the x coordinate is 2. Then we find out how far upwards or downwards we have to go. And here we can go, well, we have to go 3 downwards, so that's going to be -3. So we first of all look at the x coordinate, the 2, then the y coordinate, -3, along the corridor, up, or in this case, down the stairs. This question's all about like terms, so what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w, so 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. So the word integer just means whole number, so we're looking for all the whole numbers that x can be. Well, it says here that x is between -2 and 3. So we can first of all fill out that -1, 0, 1 and 2 are definitely values that x can be. The next thing we look at is, can it be -2? Well, there's no little equal sign underneath the inequality, so it can't be equal to -2. But there is one for the 3, so it can actually equal 3. To work out the circumference, we need the diameter, and the diameter is just the full distance across a circle. So to work out what the diameter is, we're just going to get that radius and times it by 2, which will give us 30 centimeters. The formula for the circumference is just pi times the diameter, and that's going to be pi times 30, and when you do that on the calculator you get 94.247 blah blah blah, and when you round that you will get 94.25. We rounded it to 2 decimal places because that's what the question asked us to. Rate is always something over time, so in this question we can write a quick formula of rate is volume, like released from the water bottle, over time. Now we can rearrange that so that we have, because we're looking for the amount of water or the volume of the water, we can just rearrange it so that we have volume equals rate times time. Now it says the rate is 62 milliliters per second, so we've got 62 in there. The time is 11 seconds, So we just do 62 times 11, which is 682 seconds. Not seconds, millilitres, because it's volume. So 682 is our answer. So here we have a back-to-back stem leaf diagram, and we're going to focus on just the girls first, because the right-hand one is normally easier to do. So the stem here gives us all of the tens by the looks of it, and then we put the units in here. So we've got 102 here and 105 here, so we're going to put a 2 here and a 5 here to represent 102 and 105. Now they go from biggest being the right hand side and the smallest being nearest the middle. We've got a 90, 92, so a 90 and a 92, and we've got a 73 there. And the key we can have for the girls is just 7 line 3 is 73 hours. It doesn't actually matter which value we pick. We could actually pick a value that's not on there, so 6 line 3 equals 63 hours. It's just a way of showing that that 7 represents a 10 and not a unit or anything else. Okay, so we're going to do the boys next. I'm going to pick a different colour. Now the boys gets tricky because it's actually the smaller numbers go in the middle. So when we look at 72 and 76, the order will be actually the 2 first and then the 6. Then we've got 80 and 81. So it'd be 80, then 81, and then we've got 93 there, so the 3 will go there. And the key's a bit weird as well, so if we look at this part here, it's 2 line 7 there, so let's copy that down, so 2 line 7, but that actually represents 72, so it's kind of the other way around. So the left hand side of a stem leaf diagram can be a little bit confusing. Just remember that the smaller numbers go in the middle and the biggest on the outside. So on the left hand side, the biggest will be on the left hand side. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. The formula for the volume of a cylinder is pi r squared h, with h being the height. So we've got pi times the radius 11 squared times the height, and that gives us 7,602.654 blah blah blah, and to 2 decimal places that is 7,602.65. We know that all linear graphs follow y equals mx plus c, with m being the gradient and c being the y-intercept. So looking at this equation here, we've got c is positive 5. So we know the graph is going to hit the y-axis at 5. So let's plot that. And we know for every 1 it goes to the right, it's going to go up 2 because the gradient is 2. The number before the x is 2. So if we go 1 to the right, it's going to go up 2. So that would be 7. Then another 1 to the right, it's going to go up another 2. So that's going to be 9. So that is going to be 7. And then that's going to go up to 9. So we've got to draw it in, and make sure you do it draw the line for the whole graph, not just the points that we've just plotted in. And it should be something like this. So we're asked to rotate the triangle A 90 degrees clockwise and the centre of rotation at 0, 0. So we're going to first of all just show where the centre of rotation is, which is at our origin. And what you do is you get tracing paper, trace out the triangle, and rest your pen or pencil at 0, 0. So I'm just going to draw it out. So just copy it out. And what you do is you'd push your pen into 0, 0. And unfortunately I can't do that. But when you rotate it 90 degrees clockwise, the shape will end up here. And so we just got to line this up perfectly. A little bit less rotation maybe. There we go. And then what you do is you'd lift your tracing paper and just draw in the shape underneath. And it says to label in the triangle as B. When you have a fraction, it's just a fancy way of showing a divide. So this is x to the power of 11 divided by x to the power of 3. And indices rules say that when you divide two powers with the same base, you subtract the powers. So it becomes 11 take away 3. 11 take away 3 is 8. So that's x to the power of 8. When translating, we translate with vectors. And the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape from there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. Go do a multiplication grid. And we're going to start by putting the x plus 12 at the top, so x, and then we've got 12, and the x plus 5 down the bottom, or down the side. So we're going to times these together, so x times x is x squared, x times 12 is positive 12x, x times 5 is positive 5x, and 5 times 12 is obviously positive 60. Put the terms together, and we notice that we've got two x terms there that we can add together. So we've got the 12x there and the 5x there. So when we add those together, we get 17x, and that's our answer. So our answer is x squared plus 17x plus 60. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So we're asked to find the value of n where both sequences have the same term. So I'm going to start off by equaling both nth terms to each other. And then we can find the value of n which gives the same term. So I draw my lines down. And I'm going to start off by getting rid of the n's from both sides. So we look to see which is the smaller amount. So we've got 12n and we've got 6n. So the smaller amount is the 6n. So we're going to take away 6n both sides. And so that would be 6n plus 19. And we've got rid of the 6n, so just 79. Next thing we're going to do is get rid of the 19, so take away 19 both sides. And so we've got 6n equals 79 take away 19, which is 60. And finally we just go divide the 6. And so that'll be n equals 10. So the value of n is 10. Now we can just test this, because if you do 6 times 10, which is 60, 60 plus 79, which will be 139. And then if we do the same for the top one, 12 times 10, which is 120, plus 19, which is 139. So they both have the same term when n is 10. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.